Have you heard some news about water pollution? In the past 150 years, ocean acidification has been a threat to all life forms on Earth. Carbon dioxide, when dissolved in salt water, it forms carbonic acid, which dissociate with bicarbonate and hydrogen ions. When existing in high quantities, this drastically lowers the pH level of ocean.
So what exactly causes this to happen? Well, these include carbon dioxide emissions from vehicles and agricultural or industrial processes, pollution, warm temperature, and large amounts of nitrogen and phosphorus contains in water. This phenomena results to the increase in the carbon dioxide concentration in the ocean, low dissolved oxygen levels, loss of aquatic life, food shortage, food web interference, and impacts on human health, reefs, and open ocean planktonic ecosystems. But do you know how are these detected, studied, discovered, and measured? This is now where the significance of chemistry comes in.
In ocean acidification, there is a method called electrochemical method, which uses potentiometric device such as pH meter, specifically the ISFET pH meter. According to Harvey D., this measures the potential of the electrochemical cells under static conditions. Also, there is a use of pH paper and dye, which indicates the concentration of the
For the detection of dissolved oxygen concentration, a common classical or volumetric method is the Winkler method, which uses titration for dissolved oxygen analysis at atmospheric equilibrium. 2 ml of manganese sulfate, alkali iodide azide, concentrated sulfuric acid, and starch reagents were added to the DO sample in a biological oxygen demand or BOD bottle to form a blue-colored acid, which is then neutralized by sodium thiosulfate. Like a typical titration method, an endpoint is observed when the equivalence point is reached, that is, when the solution turns from blue to clear in color. The concentration of the dissolved oxygen in the sample is equivalent to the volume in milliliters of the titrant. For every ml of sodium thiosulfate, it has a 1 mg per liter of dissolved oxygen. Other modernized analytical methods are electroanalytical and spectroscopic methods. The analyte in an electrochemical cell is examined through the measurement of the potential in volts and current in amperes. Some instruments used are galvanic, polarographic, and optical probes or sensors. Another method is called spectroscopy, which involves colorimetry by measuring the concentration of the colored compounds using a spectrophotometer.
Solving real-life problems such as ocean acidification by integrating the concepts and recognizing the role and importance of biology and other branches of science propels the utilization and further advancement of chemistry, mainly analytical chemistry. Together with you, we can protect our world. Join us now in preserving our climate and saving the environment with science. Once again, we are live in chemistry.